So this session is 5.3, which is properties of logarithm. There are two questions on the assignment where you have to deal with the properties of logarithms. And usually people struggle a little bit with those and understanding what to do. So when we look at 5.3, 5.3 covers using the change of base formula to rewrite and evaluate logarithmic expressions. Using properties of logarithms, that should say, it's a typo, not faux, of logarithms to evaluate or rewrite logarithmic expressions. Use properties of logarithms to expand or condense logarithmic expressions. This is what you need to do on the assignment. Then use logarithmic functions to model and solve real-life problems. So for this session, you're going to be needing a calculator for sure. So if you have one, it's important to understand how to use the log button on your calculator and the natural log button on your calculator. So we're going to start with the change of base formula. So when we have a logarithm, you can have it in many different bases. The most common bases are base 10 and base E, and those are the buttons that you usually have on a calculator. My calculator has a button for each one. But you can have logarithms in a different base, and if you have it like base 2 or base 5, then you can't use your calculator to find the logarithm. So you have to use a change of base formula so that you can use the calculator. So there are essentially three different formulas here. There's a formula for base B. Any base, you can use base 2 if you want. There's a formula for base 10, which is just the regular log. And then there's a formula for base E if you want to use the natural log. The way I remember the change of base formula is that whatever my base is, that goes in the denominator. And then whatever I'm taking the log of goes in the numerator. So that's how I remember which goes where. So if I just highlight these. And it's just, it doesn't matter, you can do log, you can do natural log. You get the same answer whether you use log or natural log. So my calculator has both buttons easy to access, but some calculators, like I have a graphing calculator, and the graphing calculator has a button for natural log but not for log. So when I use a graphing calculator, I usually only use natural log. But if you have a calculator that has both buttons, it doesn't really matter which one you use because you get the same answer either way. So you can use whichever one is easiest to get to on your calculator. So here's some examples. So we're given log base 1/5 of 4. And so we want to use the change of base formula to rewrite this as a ratio of the common log and the natural log. So I'm going to show you how to rewrite it for both. And then I'm going to show you that you get the same answer using both methods. So if we want to rewrite this using the common logarithm, the top common log is base 10. So the top is going to be just log 4. Just ignore the base. And the denominator would be the log of 1/5, whatever that base is. For the natural log, when I write natural log, I do it in cursive. So I do cursive L and then an N because otherwise it looks like a 1 and an N. So I use a cursive L so that it doesn't look like a number. But it's basically the same thing. The natural log of 4 divided by the natural log of 1/5. So that's rewriting it. Now, if you want to evaluate and verify that you get the same answer, you can take your calculator and find the log of 4. So my calculator gives me 0.6021 when I round it to 2 decimal places. And then I can do the log of 1/5 on my calculator. That gives me negative 0.6990 when I round that. So when I divide these two numbers, I get about negative 0.8614. Now, since my calculator also has a button for natural log, doing the natural log version is really easy. So when I take the natural log of 4, I get 1.3863. And then when I take the natural log of 1/5, I get negative 1.6094. And so when I divide those two numbers on my calculator, I get about negative 0.8614. I get the same exact answer. So you can use the change of base, you can use the log, or you can use the natural log. It doesn't matter. You get the same answer either way. So it's all about what is easiest to access on your calculator. Are there any questions on this example? All right. Example 2, I'm going to do another one where we are rewriting it, but this time we have a variable involved so that you can see how that works. So rewrite log base 2.6 x as a ratio of the common log and the natural log. So we're going to do the same thing. So x is going to be on top. It's going to be the log of x for the common log, that's base 10. And then we divide it by the log of 2.6, whatever that base is. And for the natural log, you'd have the natural log of x over the natural log of 2.6. So that's how you'd use the change of base formula if you have a variable. It's basically the same exact thing. It's just now you have this variable, so we can't simplify it to a single number. We leave the variable. And the reason why you might want to do something like this is if you have an equation where you're trying to solve for x. And if you're trying to solve for x and you have a different base, it may be harder to solve for. You may want to convert it to a log or a natural log to make it easier to solve. This is a little more useful here. Evaluate the following logarithms using the change of base formula. So this is where you're given some log and it's in a base that you can't do on your calculator, and then you want to convert it to something that you can do on your calculator so that you can evaluate it. So you can choose whether you want to do log or whether you want to do natural log. And so I'm actually going to make you guys choose because I don't know what calculators you have, so I don't know which is easiest for you. So please fill out this poll. Should I do these using the log or the natural log? I would choose the one that you can do on your calculator. That seems to be the easiest. Okay, right now we're tied. We've got 3 more people, so if you guys could vote. Okay. So far, log seems to be the highest. Okay, I'll do it with log, since that seems to be the. It doesn't beat it out by much, but it's a 2-to-1, but at least it is. We'll do these in terms of log, because I think that is what most people have on their calculator. So, actually, let me stop the poll. Okay. So, using the log, if I have log of 0.4 of 12, I'm going to have a log of 12, and then in the denominator, log of 0.4. So then I need to actually take these logs on your calculator, and actually you can do these all in one step. You don't have to in 2 separate steps, because if you have a button for log of 12, you can type in your calculator, and let me do this in a different color. So the way that I type it on my calculator is I literally type log parenthesis 12, and then I have my division log 0.4. So I can just type it in all in one step. so that I can get the answer and I don't have to round. So when I do this, I get negative 2.7119. So I usually use 4 decimal places. The textbook usually does 3 decimal places. So 3 or 4 decimal places is okay. I would not do less than 3. So when we work with logs, use 3 or 4 decimal places. If we wanted to do 3 decimal places, this would be 2.712 because that 9 would cause the second one to round up to 2. So you'd want to do either 2 or 4 decimals. Don't use less than that, and you don't really need more than that. Second one here, I have log of 2/3, log base 2/3 of 0.125. So that's going to be the log of 0.125 divided by the log of 2/3. So when you enter this on your calculator, you want to be very careful about your parentheses, especially depending on your calculator. So I can do log of 0.125 divided by log parenthesis 2 divided by 3. So I have to make sure that I have parentheses in there so that you're not doing log base of 2 and then dividing by 3. So the parentheses are really important to make sure you're doing that 2 divided by 3 before you take the log. So when I enter this, and on my calculator, it's really important to close the parentheses too, because if you don't, you can get an error. I get 5.1285, which if we were using 3 decimal places would be 5.129. Do you guys have any questions? Okay. So moving on to the properties of logs, this is what you need for the assignment. So A is our base. Just you have to have a positive base. So we need to have a positive base. That's a requirement. And it's not going to be base 1. It's usually base 10 or a natural log. It says let n be a real number. That's just an exponent. So our exponents can be positive or negative. U and V must be positive real numbers. So just as a note, we can only have positive numbers inside a log. So we can only do a log or natural log of positive numbers. So if you have any negatives, you're going to get an error. So that's why they're specifying that U and V are positive, because you have to have positives in there. So we have 3 properties. We have the product property, the quotient property, and the power property. And these are related to the rules of exponents. So a logarithm is basically doing the opposite of an exponent. So let me put the rules of exponents over here. I'm just going to abbreviate exponents. So the product property of exponents would be a to the u times a to the v is a to the u plus v. So there is that rule of exponents where if you're multiplying, you add the exponents. So this matches with our product property of logarithms. We're multiplying, and then it turns into addition. So the logarithms are basically working on the exponents. So when you're multiplying exponents, you add the exponents. So if you're multiplying inside a log, you can turn it into addition. Next is the quotient property. So when we have exponents, that would be a to the u over a to the v. Why am I Sometimes these disappear. It keeps disappearing on me. Let's a to the v. I don't know why it does this. There we go. Ah, it disappeared again. This hates me. Okay, I'm going to try to move it over. A to the u over a to the v. You subtract the exponents, the top minus the bottom. So it's very similar to the quotient property with logarithms, where if you're dividing with a logarithm, it's subtraction. So if we're dividing with exponents, we subtract the exponents. So those are related. And then our last one is the power property. So this would be if we had, let's see, let's try this again. A to the u to the n. So when you have a power of a power, you multiply those. Those are a to the u times n. When we have something that is a logarithm, if you have something like u to the n goes front. It's n times the logarithm, so you're still multiplying there. So that comes from this rule right here, where if you have an exponent, then you multiply them. So these rules of exponents, they're translating to the rules of logarithms. And the rules for logarithms are the same whether you're doing it with a base a, you can have base 10, or you can do a natural log. The rules are the same. If you have a logarithm and you're multiplying, you can turn that into addition. A logarithm of like a fraction turns into subtraction. And then when you have a log with an exponent, the exponent basically gets multiplied. That goes down in front. So I usually will take that and then indicate that that's going in front of the natural log. That's how I usually write that. And then there is no property if you have addition inside the log. You can't simplify that, so you just have to leave it as it is. So let's take a look at how these are actually used. So we're going to use the properties of logarithms to write the logarithm in terms of log base 3 of 5 and log base 3 of 7. So I'm just going to rewrite it. So instead of having, like for this first one, I have a log base 3 of 5 over 7. I'm going to use the property so that I only have log base 3 5 and log base 3 7. This process is very similar to what people had to do before there was calculators. So going back to the history of logarithms were invented or kind of discovered in the 1700s, obviously before calculators. And so you would have tables of logarithms. People would compute the log of different bases of different values, and you would have these tables, and then you had to use those tables to find logs of more complicated things, such as things with fractions, because you didn't have a calculator that would do it for you. So we don't have to do this today, but it's good to kind of understand how it works and how people used to have it do it. So you have appreciation of the calculators and the fact that, oh goodness, at least we don't have to look up a big giant book of logarithms like people used to have to do. So looking at this first example, we have a log base 3, 5 over 7. So we're going to use the property where we have a division here. We have a fraction. So that's going to turn into subtraction. So this would be the log base 3 of 5 minus log base 3 of 7. So it's always the top minus the bottom. And now we only have it in terms of log base 3 of 5 and log base 3 of 7. So then if you had a table of logarithms, you'd look up what is the log base 3 of 5, log base 3 of 7, find those numbers and subtract them. Most tables of logarithms actually were in like base 10 or base 7, so you would even have to do the change base formula. So having to do these by hand was a bit harder. The next one here is log base 3 of 175. So this one is a little trickier because 175, we don't have, it's not like 5 times 7. So we need to first break 175 down into a product of primes so that we can see how we can work this. So I am going to make a factor tree. So I have 175. And I know that I can divide that by 25. And I know that because 75 is divisible by 25. And so when I divide 125 by 25, I get 7. And then 25 is 5 times 5. And so now these are my primes. And so if I wrote this as a product of primes, it would be 5 squared because I have 2 of them. And then times 7. So going back to our original problem, instead of log base 3 of 175, we have log base 3 of 5 squared times 7. Now I have multiplication in there, 5 squared times 7. Multiplication, you turn it into addition. So this is log base 3 of 5 squared plus log base 3 of 7. Now I need to use the property. I have an exponent, and when we're simplifying or we're trying to rewrite these, we don't want to have exponents there. So I am going to be taking this exponent of 2, and our property says that we can do 2 times our logarithm, so that can go in front as multiplication. So this would be 2 times log base 3 of 5 plus log base 3 of 7. And now I'm done because now I have it simplified so that I have the only log stuff I have is log base 3 of 5 and log base 3 of 7. And then I don't have any exponents. So that's how I know that I am done here and that I have rewritten it as we've been asked to. Are there questions? Do you need to put parentheses before the 2? So if you were to, let's say you were going to try to do this on your calculator or something, let's see. Oh, after the 2, like around the log 3 of 5. You don't have to. You can, though, if you want to make sure that it's clear. So it's generally assumed that the number that immediately follows the log kind of goes with the log, so you don't have to, but if you want, you could do that, and that's fine. We assume that that 2 is only getting multiplied by the log and not the rest of it. But you can do whatever makes sense to you. I usually, like, some people don't even put a dot there and they just write 2 log, whoops, accidentally erased too much, 2 log 5. I think that gets a little confusing, so that's why I do 2 dots, so that it's showing that I'm just multiplying the 2 by that log and not the whole thing. If I was multiplying by the whole thing, then I would put parentheses around it. Are there any other questions? Actually, let me just do in another color here. If we had, let's say instead of log, that square was outside like that. Instead of having 5 squared times 7, it was 5 times 7 squared. What you would do here is first you'd put that 2 in front. So it'd be 2 times the log base 3 of 5 times 7. And then this would be a case where you do need parentheses because the 2 is getting multiplied by everything here. Log base 3 of 5 and log base 3 of 7. So that's the difference. As if that exponent is on everything, then it goes in front and you would need parentheses. But if it's just on one of the individual ones, then you don't need parentheses. Does that help? Good. Okay. That's a good question. All right. So now we're going to kind of show you how you can do use these sort of tricks to find the exact value of a logarithm without using a calculator. So this is just, again, you wouldn't have to necessarily do this in real life because you have calculators, but it's a good way to get practice with the properties of exponents. And if you're wondering, well, if our calculators do this, why do we need to know these properties of exponents? It's because when you start solving, when you get to like 5.4 and 5.5, you start using the properties of exponents. And then when you go on to calculus, knowing the properties, or I keep saying properties of exponents, properties of logarithms, I mean. So you'll need the properties of logarithms to solve in 5.4 and 5.5. And then when you get to calculus, the properties of logarithms can make your life easier. So the purpose of problems like this is just so you get practice with them. Even if you're never going to have to do an exact example like this in real life, it's a good way to give you practice. So we're going to find the exact value of the logarithmic expression without using a calculator. So the first one, I have log base 5 of 1 over 125. The goal of doing a problem like this is to rewrite whatever you're taking the log of so that it has a base of 5. It's going to be an exponent with something that's a base of 5 because we have log base 5. So 125 is 5 cubed. That's just something that I happen to know. You can do a factor tree to figure that out, but 5 cubed is 125. So instead of writing 1 over 125, I can write 1 over 5 cubed. Now 1 over 5 cubed, I can rewrite this so that I have a negative exponent. So that's the same thing as having 5 to the negative 3. And when you go on a calculus, you actually have to do that a lot, rewrite things with negative exponents. Now I'm going to use the property of logs that says that exponent goes in front and gets multiplied. So that would give me negative 3 times log base 5 of 5. Now, if you have the base and what you're taking the log of the same, that is equal to 1. They basically cancel out. That was covered in 5.2 when you're reading 5.2, and it introduces you to what a logarithm is. So I'm going to just write that up here. Log of, say, a of a is equal to 1. So those just cancel out. So if I had the log of 10, that is equal to 1 because it's log base 10 of 10. And the natural log of e is also equal to 1 because the base of the natural log is e. So knowing that that is equal to 1, this is, oops, I accidentally turned my pen off. This is negative 3 times 1, or just negative 3. And so we found the exact value of the logarithm without using a calculator. If you wanted to, you could do the change of base formula and do it on a calculator. If you do that, oh, sorry, I accidentally hit my microphone. If you do that on the calculator, you're going to get probably like negative 2.999 or something. It's not going to be exact, but it will round to negative 3. The downside of using a calculator is that you can't get the exact value. You always get something that's a rounded version. And so you just want to be aware of that. And if it looks like it rounds to a whole number, then it's probably supposed to be a whole number. The second example here, I have the natural log of 1 over the square root of e. So first, I need to turn that square root to the exponent form. And that's another skill that you have to use when you go on to calculus. So instead of writing 1 over the square root of e, the square root is equal to the 1/2 power. So I'm going to change that to 1 over e to the 1/2. Then I'm going to use the same trick where I'm going to make that have a negative exponent. So that's e to the negative 1/2. Then that exponent can go in front and be multiplied. So that would be negative 1/2 times the natural log of e. And then the natural log of e is just 1, so that's going to be negative 1/2. And if you have, let's see, if I can actually just put this in my calculator, because I have a natural log button, I can type in literally the natural log of 1 divided by the square root of e. And my calculator gives me, actually the calculator does it exactly. My calculator tells me it's negative 0.5, which is negative 1/2. Are there any questions on these two examples? Okay. Moving on to my next example. Now, these are the types of things that you're going to be doing on the assignment. We're going to be expanding, so it's going to become bigger, and then we're going to be compressing, so we're going to make it smaller. These are the types of skills that you need when you go on to calculus. So that's why we're practicing these skills, because in calculus they don't teach you. Think of college algebra as preparing you for going on to calculus. The first half of college algebra is basically preparing anybody that needs to go into business. So you go through the first half, you know everything you need to do, like a business degree or statistics. Second half of college algebra is for those who are going on to calculus. You're learning the skills that you need to know when you get to calculus, because you're not going to be taught these things. You need to know it. So this is one of those things that for those who are in engineering or computer science and need to take calculus, this is going to be a skill that you're going to need to know how to do, because it'll make your life easier. So we're going to use the properties of logarithms to expand the expression. So that means we're going to turn all multiplication into addition things, and all division, all fractions into subtraction. So we're going to make it bigger. So hopefully I have enough room here, but I probably don't. I probably don't have enough. These aren't wide enough, but we'll see. So a first one here, log base 4 of 11 times b squared times c. So we have three things that are multiplied together, so I can turn that into three different additions. So that's going to be the log base 4 of 11 plus log base 4 of b squared plus log base 4 of c. So those are all multiplied, so I use the property of logs to turn them into addition. The next step is to take all of your exponents and put them down in front. So that means I have log base 4 of 11 plus 2 times log base 4 of b plus log base 4 of c. Once I've done that, there's nothing more that I can do. I'm expanding, I'm not trying to evaluate, so I'm not going to simplify by using change of base on the log base 4 of 11 or anything. I've expanded it out, I've made it bigger. So that's what we need to do. This is a skill that's helpful when you're doing, when you need to do integration when you get to calculus. So for anybody who's watching this and going to calculus, you may want to make a little note of that. So that way, you know, when you're in calculus, you can go back to your notes and be like, aha, this is something that we need to do. Now the second one, I'm going to do this in a different color just in case I run out of room and I need to expand. We have the natural log. We have the cubed root of y z over x squared. So the first thing I need to do, because whenever we're working with logs or natural logs, you need to have exponents, not roots. So I need to convert that cubed root to the 1/3 power, because that's what the definition of the cubed root is. So this is going to be the natural log of yz over x squared to the 1/3 power. Now, I'm going to take my rule of exponents, or I mean the rule of logarithms that says that my exponent can go down in front, so that I can get rid of that and then I can work with what's inside. So that's going to give me 1/3, and now I'm going to have, well, in this case I don't need the parentheses yet, times the natural log of yz over x squared. So now I have a fraction, so this is where I need to turn it into subtraction. So I'm going to take the yz as 1, and then I'm going to subtract the x squared. And this is where I need to have the parentheses, because that 1/3 is times everything here. So I'm going to have the natural log of yz, that's the top, minus the natural log of x squared. I'm not done here, because now I have the natural log of yz that's multiplied, so now I need to expand that further by turning that into addition. And I'm definitely going to run out of room, so I'm going to move over here. So I have my 1/3. Then I turn the natural log of yz to the natural log of y plus the natural log of z. Then I have this natural log of x squared. Now I want to get rid of this exponent by putting it in front. So now this gives me 1/3 times the natural log of y plus the natural log of z minus 2 times the natural log of x. And now I have expanded that out. You can leave it like this, or if you want, you can multiply the 1/3 through. And if you do that, I'm going to have to make this really small. You can have the natural log of 1/3 times the natural log of y plus 1/3 times the natural log of z minus, and then you'd have 1/3 times 2, so that'd be 2/3 times the natural log of x. Either one of those last two lines are correct for your final answer, because you can see that they didn't really add to the expansion. They're about the same size. So you can use either one. But you can see that we definitely took something that was much smaller, and now we have expanded it out by using the properties of logarithms. Do you guys have any questions on either one of those examples? So far, so good. That's good. This kind of thing is where most people lose points when it comes to the final exam, because the final exam has things from, week 7, and this is usually one of the lower scoring questions, is trying to do this. Okay, so now these are my last two examples. Now we have something that's expanded, and now we're going to compress it. So now we're going to make it smaller. We're condensing it out. So we're kind of reversing what we just did. So I have 2 times log base 2 of x plus 4 times log base 2 of y. When you're condensing, the first thing you do is that now you take those numbers in front and you turn them into exponents. So we're reversing everything that we've done previously. So now it's going to be the log base 2 of x squared plus log base 2 of y to the 4th. So all the numbers in front become exponents. Now we're reducing, or we're condensing it. So now all the addition becomes multiplication. So this will give us log base 2 of x squared y to the 4th. And now we've condensed it. We can't do anything else. So now what we have is a condensed expression. Now all of the examples that I've given, the base has been the same on all of these. You could only condense if the base matches. So these both had base 2, so I can condense those. If one of them was base 2 and the other one base 3 or any other base, they cannot be condensed. So just watch out when you're condensing expressions. You have to make sure the base is the same in order for you to combine them. So we didn't have to worry about that in any of the other problems because we weren't condensing, we were expanding out. But here we're okay, they're both base 2. And usually for examples like this, you're given ones where they're going to be the same base. Second example here, I have 2 times the natural log of 8 minus 5 times the natural log of z minus 4. So just like with the other one, all of those numbers in front become exponents. So this is going to be the natural log of 8 squared minus the natural log of z minus 4 squared. I can actually do 8 squared, so I can turn that into the natural log of 64. That's actually more condensed. We are not going to do z minus 4 squared. That's not going to condense it anyway. It's actually going to make it look a little kind of messier, so we're going to leave that as it is. Now we have subtraction. Oh, I have a question. Let's see. Not, oh, yeah, 5th power. Thank you. Thank you for pointing that out. Yes, because that was a 5 in front, so those should be the 5th power. Yeah, we definitely don't want to do z minus 4 to the 5th power. That would be really hard to multiply that out. Good catch. So now that I've corrected that, now we have subtraction that gets turned into division when we're reversing this. So it's going to be the natural log, and then I'm going to make sure I have parentheses so that it's clear. I have 64 on top, then z minus 4 to the 5th power in the bottom. And then that's as condensed as we can get. And so that would be your final answer there, is the natural log of 64 over, and then z minus 4 to the 5th power. The textbook has ones that are a lot more complicated than this. These are basically the same sort of level you have on the assignment. The textbook does have in the practice problems for 5.3 some more complicated ones. So if you do want more practice, I encourage you to do those to see if you can do the more complicated ones. It's just a matter of doing it step by step. Don't try to get overwhelmed. Don't try to do more than one step at once. Just do step by step by step. Do you guys have any questions? All right. So that was all I had for this section. This should also help you out once I have videos on 5.4 and 5.5 already in the classroom. So if you watch those videos next, you should have some basics of the rules so that when we start solving, things will look familiar. But if you do have questions, of course, you can email me. You can call my office phone number. And that's all I had for you guys. So I'm going to put back, I can put my webcam back on and stop sharing. All right, so I feel like my hair around my is kind of crazy. So our next live session is actually going to be an open question and answer. where you can just come, ask questions, hang out, do your homework while I'm sitting. I'll be on this for an hour, just available for you basically. So that is going to be Tuesday at 7 p.m. Central Time. So you can pop in and out if you want. You can show up with questions, or you can show up with no questions and see if anybody else has questions. But that's just going to be an open session where you can, if you want to see more problems worked out, or if you have questions, that's next. So thank you guys so much for showing up on a Saturday. I appreciate taking out your time. I'm sure you guys have busy weekends trying to catch up with things that you can't do during the week, So, yeah, so hopefully I'll get this out within the next hour, depending. I imagine it should process pretty quickly because I don't think people use I don't think Blackboard should be too bogged down in the middle of the day. So hopefully I'll see you guys on Tuesday night. If not, hopefully I'll see you on Wednesday, which will be our introduction. And the week 8 introduction on Wednesday is going to be at 6 o'clock. 6 o'clock Central, so you can put that on your calendar. I know probably some people will be traveling for the holidays, so you might have to just watch the recording for that one. But all right, so that's all I have for you guys. Thank you so much, and I will see you guys again. Bye.